Hello friends, welcome to Electronic Circuit Hub. So today I'm gonna show you about the switched capacitor voltage inverter circuit. We will understand how this circuit works, how you can use capacitor to invert your supply voltage, okay, how you can generate a negative supply voltage in LTSpice. So friends, if you are new to this channel, please join the channel membership by clicking on the join button. Once you click on the join button, you can see here the different options. You can join the premium membership, you can join the LTSpice simulation help, and you can also join the popular program, that is mentorship program, okay, by clicking here on the join button. Now let us understand the switched capacitor voltage inverter circuit. Okay, the switched, this is also known as switched capacitor topology. Let us understand how this topology you can design and how you can generate the negative power supply, right? Let's say you have your positive inputs. In this case I have 12 volt as a positive input, and I want to generate minus 12 volt for my application. So I have used switched capacitor topology. Okay, so let us understand first the circuit flow, then later I'll run the transient analysis and I'll show you the output here, right? So you can see here, this is the V1. So let us say in your design you have 12 volt power supply, okay, and you want to generate minus 12 volt power supply. Okay, so you can use this topology. This is called switched capacitor voltage inverter topology. Okay, so here you can see I have used 4 voltage control switch. Okay, the switch S1, S2, S3 and S4 are 4 voltage control switch. If I say the voltage control switch, that means that they are turning on and off by using a square pulse. Here you can see, so this V2 is a square pulse, and if I right click on this V2, you can see the on is V on is 5 volt, and the T on is 1 microsecond, and the T period is 2 microsecond. So by using this voltage source, the pulsating DC voltage source, I am controlling my 4 switch. Okay, you can see switch 1, switch 2, switch 3 and switch 4. Okay, so you can see here this positive terminal of this V2 is connected to the positive terminal of S1, and the negative terminal of S1 is grounded, and at the same time you can see this again positive terminal is connected to positive terminal of S2, and the negative terminal is grounded. And for the switch 3 as well as switch 4, you can see the positive terminal is controlled by this square pulse V2, and negative terminal is grounded for all 4 switches. Okay, now you can see here, this is very important to understand here guys, how you can connect the capacitor in between the switches and how you can make the connections. Okay, so you can see here for the switch 1, this 12 volt is connected here for one end of S1, the other end of S1 is connected via a capacitor C1, and at this junction you can see I have connected the switch 3, right? I have connected the switch 3. Now other end of C1 is connected to switch 2 here, right? And you can see this switch 2 other end is grounded. Okay, now from here I have connected to switch 4. You can see this, before the capacitor I have connected to switch 3, and after the capacitor I have connected to switch 2. Now you can see from here switch 2, I have connected this point to the ground, and I have also connected one capacitor. This is 1 microfarad capacitor, and this point is connected to 1 microfarad capacitor, and R1 is load. Okay, so now let us rename here. So let us say here you will get inverted voltage, right? Inverted voltage. So this point is, I would say, let me check if this allow this. Okay, this is along. So this is your inverted voltage point, right? And this, let me say, this is your Vin. Let me label it. This is your Vin, and this is your controlling signal here, right? This is your controlling signal. So I will rename it switch control, SW control, CONTROL, right? Okay, so all things are set now. Let me quickly run the simulation transient analysis, and let me show you how this circuit behaving, whether you are getting your output voltage, negative output voltage or not, okay, by using this switched capacitor topology. So right away I'll run the simulation. I'll click on the simulation. One more thing I would like to mention here, if you're using the voltage control switch here, you have to write the model for this. So I have written the model for switch 1, switch 2, switch 3 and switch 4, right? You can see here, this you have to write, otherwise your voltage control switch won't work. Now let me go to window, trial window vertically. Let me show you first the control voltage. So this is your control voltage, this is your control signal, guys, right? You can see this is your control signal, right? This is your control signal. This is your input voltage, which is 12 volt. Now let me show you the output voltage here. Bingo. Okay, so let me show you the output voltage, how the output voltage looks like. You can see here, this is the -12. This is your input. You can see your V in is 12 volt in the blue, and you can see V inverted is -12 volt. Can you see, guys? 11.95 volt. If you a little bit zoom here, you can see how your signal looks like, how your input signal is looking like that. Let me zoom it more. You can see how your signal is rising, right? It's -0 volt, then it's keep on rising and it reaches the steady state condition. Now here you can see you have the 12 volt. So this is your input, okay, and this is your output. Here you are, this is your input and this is your output. You can clearly see, guys, whatever your input voltage, you are getting the inverted output, right? You are getting the inverted output, okay, by using this topology. Let me change this 12 volt to 5 volt and let me check if we are getting 5 volt at output. That means your circuit is working or not. Okay, now let me show you, this is your input, which you can clearly see is 5 volt, and here you can see you have what is, you have 5 volt output with the negative. You can see this is -5 volt. Okay, so that is how, guys, you can use this topology to generate the negative voltage. Okay, this is called switched capacitor topology, and it is, if you're using for your negative supply for low power application, like, you can use this very popular topology, switched capacitor topology, to generate the inverted voltage, or you can also generate the negative voltage by using this kind of the topology. Okay, so hope, guys, you have understood how you can design the switched capacitor topology in LTSpice, how you can simulate the behavior of this circuit, right? This is, if you Google it, you can find this topology over the internet. You can easily find and you can check whether this circuit is matching with those circuits or not, because I have taken the reference from internet to design this circuit in the LTSpice. Okay, you, in spite of switch, voltage control switch, you can also use other switch like MOSFET, whatever you have in your design. You can use those switch to generate this kind of voltage. Okay, so hope you understood this topology. You are now able to design and simulate the switch capacitor voltage inverter in LTSpice. If you have any further question, feel free to ask me in comment section. Thank you for watching this video.